Okay, so 1.5 in the IM2 book is about radicals and rational exponents. Today we'll be using calculators, but you only need a scientific calculator. And in this video, if you see a pause sign, you only have to pause it long enough to do the problems. We're going to work them out right away rather than at the end. So this is something you should familiarize yourself with in your journal. It's also in the textbook. So read through it, make sure that you understand each thing. I'm going to go through them in the next few slides. So the radical symbol is used to indicate roots. The index is the small number that to the left of the radical symbol that tells which root to take. If there is no root, if there's nothing there, then it's asking for the square root. Okay? And so if you see this one, this is an example down here, you see the cube root of 8. It's asking you what number times itself 3 times is equal to 8. So that's how you got that answer. Okay, up here there's just some examples. Again, it's showing you if there's nothing there, it's a square root. And then if you have a 4, it's the 4th root, etc. So the way I thought of to remember this is to remember that when you're putting this into the rational form, so this is the radical form, into the rational form, rational exponent form, the top number is the exponent that's right here. So if there's no number there, it's a 1. Okay? And the bottom number is the root, which goes where the roots of a tree grow. Okay? So if I had 25 squared and I wanted the cube root of that, that would be 25 exponent on top over the cube root. Okay, the cube root of a equals a to the 1/3, and it's asking you to find what is the cube root of a. So this is asking you what's the cube root of 8, which we know is 2. This one's asking you for the square root of 81, and this is the radical form, and this is the rational exponent form. Some people call them fractional exponents for an obvious reason. And this is just reminding you that if this is 0, then it doesn't matter what n is, it will equal 0. And if b equals 1, doesn't matter what n is, it will equal 1. Okay, in these problems on the extra practice on page 125, they are asking you to put them in radical and rational form and also to solve them using, if you know it, fine, but if you use a calculator, I want to show you how to do that. So number 1 and number 12 are square roots, and these are the keys. The red ones I've marked are the ones that you would use. So this is 64 to the 1/2, or the square root of 64. Now to get that on the calculator, you would type in second, which is this key, and that takes you to the instructions above the x squared key. So you're going to hit the x squared key, but it's actually going to be giving you this. So you hit this key, and then you hit 64, and that will give you the answer of 8. Okay, so it's saying the second square root of 64 is 8, or the square root of 64 is 8. This is just telling it to take the instructions from the upper instruction. Okay, this next one, these are all various roots, and you're going to use a different key. This one's the same, but this one is different. So make sure you notice which key that is. This would be written the 8th root of 256, or 256 to the 1/8. Now, first thing you're going to do is you're going to type in the root. Okay? So you're going to just type in 8, or hit the 8 key. Okay? Then you're going to hit second again, which is going to take you to the instruction above this key, which is, looks like that. But this is the key you're hitting, okay? And then you're going to type in 256 and then equals. And that will give you the answer 2. So be very careful of your steps. Hit the 8, then the second, then the up, then type in 256, and then equal. Okay, so a fractional exponent can have a numerator other than 1, as in the expression b to the 2/3. You can write the exponent as a product in two different ways. So this is root first, and what that means is you would, and this is exponent first, okay? So you're separating it because 2 times 1/3 is 2/3. So the next step would be to find the power of a property. So this one, you solve the root first, and then you do the other exponent after. This would be doing the exponent first, and then doing the root. The reason I liked this one best is because sometimes when you square the numbers they give you, they get so big that you have to use a calculator to do this. But often if you do the root first, then you can do this without looking at a calculator. And so then the answer, this is how they do that, the definition of b over 1, and this is just another way of writing it. But you'll get the same answer either way. Okay? Okay, so look at number 13 on page 26. They want you to tell them how to write that in rational form. So I write my base, I make a fraction, I remember that my root goes underneath, and my equation goes on top. You could also write this one like that. Okay, so this is just going to show you step by step with instructions on how to do this with the rational exponents. So the first thing you're going to do is divide the exponent into two pieces. You first have to evaluate which you're going to do, the root or the power. On the previous slide it explained the differences, and then you put one inside the parentheses and the other on the outside. In this case I did the root. Now obviously you're not going to have to show all of these steps. For example, you're not going to show this step on your homework, it's kind of silly, but I would do the next step, which is 3, which is the answer of 9 to the 1/2, and then you just get your final answer, which is your last step. Okay, now when your exponent is greater than -1, there's a cool shortcut that one of my students developed many years ago. So see that this is greater than -1. So what Nathan did was he made it an improper fraction, and then he divided it into two separate parts. So we have the 81 to the 1 times 81 to the 1/4. Keep in mind, if we were to multiply these together, we add the exponents and we get back to 1 and 1/4. So the ease of doing this is you have a smaller radical here and you know you're multiplying it by 1. So then we just do 81 times the 4th root of 81 and we get our answer. Okay, you can still do it this way and solve it and get 3 to the 5th, which is also 243, but most students, once they learn Nathan's method, like that the best. Okay, when you're solving a word problem, the biggest mistake that kids make is they plug in the number into the wrong place. So be careful. So this one says the surface area is 54. So I'm going to keep that in parentheses because the first thing I want to do is simplify. So volume equals 9 to the 3/2. And at this point I can do it the one way, which is 9 to the 1/2 cubed, which is 3 cubed, which is 27. Or I could do Nathan's method, which is 9 to the 1/2, which is 9 times the cube root of 9, or the square root of 9, which is 3, which is 27. So you're going to get the same answer either way. The thing you needed to learn from this slide is to be careful plugging things in and simplify first. Okay. All right, this one's about food. So the approximate number of calories C that an animal needs each day is given by this formula, where m is the animal's mass in kilograms. So they want you to find the number of calories that an 81 kilogram panda needs every day. So again, I'm looking for the C. I go 72 times 81 to the 3/4. Now I want you to stop and ask, why did I put that in there? And the reason I did is to remind you that the exponent only goes to that number. So then I'm going to go over here and I'm going to solve that 81 to the 3/4. And so the fourth root of 81 is 3. So I get 72 times 27. A lot of students will stop here and say, oh, it's 27. And they'll forget to put it back inside the equation and solve. So that panda needs 1,944 calories per day to maintain health. So if you're going to be a zookeeper, that's the kind of stuff you need to know. You're still going to be using math. This slide is to remind you that the properties of regular exponents apply to rational exponents. For example, this first one is showing you the product of two exponents with the same base, how you add the exponents. Well, if we had 3 1/2 times 3 1/2, we would add the exponents, and we would get 3 to the 4/2, or 2, which is 3 squared, 9. The next example is a power raised to a power, and when we have those, we multiply the exponents. So again, if we had this example, 4 to the 3/2 times 2, we would multiply, and remember in this example, you've got 4 to the 3/2 times 2, the 2's cancel, that becomes 4 to the 3rd, and that is 64. The next example is a product raised to a power, so you would distribute, and you do the same thing for this. Now for this one, obviously, you could distribute to each one, and you get the square root of 9 times the square root of 4 equals 6. Or, in this case, it ends up being a perfect square, so it would be 6 as well. So you can choose on that one. Okay, so now you're going to do this journal work. I'm going to explain what to do, and then you're going to pause it, and then we'll go over them right away. So for the first one, you're just going to write it in radical form. That means with the square root sign. This one, you're going to evaluate the expression, meaning give the answer, okay, the simplified answer. And this one, you're just going to solve the problem. So pause the video here and work those out and see how you do. Okay, so here are the answers. Now when I did number 16, I actually wrote it a little bit differently, but you will get the same answer. So what I did was I wrote the square root of -3 squared to the 5th power. And I worked them both out, and you get the same answer. They put the square outside, I put the square inside. It doesn't really matter. Okay, so that's what I did, but make sure that you have the parentheses, or have it like this, to show that you're taking, they put the parentheses here, I put them inside. Make sure you're showing that it is a negative base, okay, and the exponent goes to the negative base. Okay, so for this one, we know that this one is no solution because the root is -64, and you can't take the you can't take the square root of a negative number. We're not going to get into imaginary numbers at this time. Okay, the next one, you would write 256 to the 1/8 and take the 7th power of that. So we know that this is 2 to the 7th equals 128. And one of the cool things this shows you is that when you look at 276, so 2, 2, 3, 4, 5, 6, 7, 8, and they're asking for the 7th root, they're just asking you for this part of it. So it's 7/8 of the whole. Just a way of looking at it. Okay, so for this one, the radius of the sphere, they're giving you the surface area is 1493, and we're putting that over the 4 times 3.14, Okay, parentheses to the 1/2. So you want to solve what's in here first. So I did 1493 divided by 12,5,664 to the 1/2, and that is approximately 118.81 to the 1/2, and that's how they got that answer. Okay? Okay, so on this, they want you to understand what each of these means. If x, which is the base, is positive, and the n is the, okay, if n is even, then x to the n is this. So I'm just going to give you a bunch of examples. So for the first one, so we'll just call these A, B, C, and D. So for A, I came up with the example of 25 to the 4th. So I have a positive number here, an even number here, and the exponent is the same, so it's also even. So then that would be 25 to the 4 over 2, which is 25 squared, which is 625. And that is a positive number. Okay, B, I did x is negative, so I put a negative 25 in there, and I used the same radicals, but you have to be careful. So this is negative 25 to the 4 over 2, and that would be negative 25 squared, which is also going to be 625 because the negative gets squared, which makes it positive. And C, I did the cube root because they want n to be odd, and I did 81 because it's a positive number, and I'm going to do another odd number. So that equals 81 to the 9 over 3 equals 81 to the third, which is another even number, 531,441. Okay, and I'm going to do D. I'm going to erase 1. I'm going to erase all the ink. Great. And now I'm going to go back to my pens, and I'm going to do the last one, which is D. That was this one. And they wanted you to use a negative base, a negative base, and an odd number out here and an odd number here. So that becomes negative 81 to the 9 over 3, and that becomes negative 81 cubed, and that's going to be a negative because a negative times a negative is a positive times another negative is a negative number. So there you go. So that's just showing you examples of all of those. This is reminding you that when n is even, you must simplify to an absolute value. Now, they're giving you this rule because you don't know whether x is positive or negative. But when n is odd, you simplify to this because the only way it could have an answer is if it's odd. Now, after they give you that big rule and it's kind of confusing, they say, but when you are told that all variables represent non-negative numbers, meaning you don't have to worry about negatives, you don't need to use the absolute values in your answer. So if you'll notice in your homework, they give you that rule so you never have to worry about doing this. Okay? All right. So you need to pause this, simplify each one. You can only simplify, there's no equal sign. And when you're done, hit go again and we'll go over the problems. Okay, so this one is a to the 4 over 4, b to the 20 over 4, which equals a to the 1, b to the 5th. Okay, over here we're going to distribute the 1/2 to either one, so we get x to the 6 times 1/2 is 3, y to the 4 to the 1/2 times 1/2 is 2, and then this one over here is y to the 2 over 2, which is 1. So we've got x cubed, y to the 2 plus 1 is 3. Okay, we're going to do this again on the next page. So pause the video, simplify, and then start it again when you're ready to check your answers. Okay, this one is x to the 4 over 4. This one is y to the 12 over 4. So that equals x to the 1. We don't need the 1 there, but I'm just showing you. And y to the 3. Over here, we're going to distribute the 2. Don't forget to distribute to both. So I get x squared y to the 2 over 2, which is y to the 1, over x to the 5 over 5, which is 1. So I've got x squared over y to the over x. This x canceled out one of those, and my final answer is xy. Okay, do this again. You're going to simplify. They want you to simplify each expression. In other words, what does it equal? So when you're ready, pause, and when you're ready to check your answers, hit go again. Okay, so the answer to the first one is 2, because 2 times 2 times 2 times 2 is 16, and the fourth root, 1/4 root, is 2. Okay, the square root of 144 is 12, and the cube root of 27 is 3, so the answer to the next one is 9. For this one, you could choose to go 81 to the 1/2, which is 81 times 9, or you could do 81 to the 1/2, which is 9 cubed, or 9 cubed. Either way, it is 729. And for this one, when you see a big number on the root, the root, you know that it's going to be a small number. So chances are it's going to be 2 or 3, because after that they get too big. So again, you would do 64 to the 1/6 to the 7th, which is 2 to the 7th, which is 128. Or you could also do 64 times 2, because you know there's only 1 2 left over. So that's a way to check it. But this is the best way for that one. Okay, so this is a problem. In an experiment, the approximate population P of a bacteria colony is given by the equation, or the expression, P equals 15t to the 5/3, where t is the number of days since the start of the experiment. Find the population of the colony on the 8th day. So you need to pause and figure this out, and when you're ready to come back and check your answer, then hit go again. Okay, the first thing I want to remember is that this is 15 times t, which is going to be 8 in this case, to the 5/3. So I have to solve this before I can multiply it by the 15. So I'm going to go over here and I'm going to go 8 to the 1/3 to the 5th. And I know that the cube root of 8 is 2, so 2 to the 5th is 32. Again, you could use Nathan's method and go 8 to the 1 2/3 if you wanted to. That would be 8 times 4. Okay, same thing. So now I'm going to take the 32 back here, and I'm going to multiply it, and that tells me that the answer is 480. So that's how many of the bacteria there are on the 8th day. Okay, again, when you're ready to work these problems out, push the pause button, and then you'll look back at it, start it up again when you're done and ready to check your answers. Okay, this one is x to the 10/2, z to the 5/5, so that's x to the 5th, z to the 1. Okay, this one I'm going to distribute the 4 to both of these. I get a to the 16, b to the 4/4, and I translate this one to b to the 3/3. So both of those are 1s. So my final answer is a to the 16, b squared. Okay, that concludes our video for today. This one was a little longer because we went over all the answers, but hopefully that will clarify all your questions. Bye.